Welcome to The Explainer. For as long as we've been human, it feels like we've been looking up at the stars. So today, we're going to dive into that story. How did we go from seeing just a bunch of twinkling lights to understanding this vast, incredible universe we live in? It's a real detective story, full of puzzles, amazing breakthroughs, and moments that totally changed how we see ourselves.
So, why have we always been so obsessed with the stars? Well, you might think it's all about wonder and imagination, right? But for our earliest ancestors, looking up at the sky, it was a matter of survival.
Think about it. Before we had clocks or calendars or, GPS on our phones, the sky was everything. You could look up, and the regular, predictable patterns of the sun, moon, and stars told you everything you needed to know: when to plant your crops, how to guide your ships across these huge, empty oceans. It even shaped entire religions. The cosmos was literally their clock and their map, all rolled into one.
Okay, so the stars move in this nice, predictable way, like a giant celestial machine. But as people kept watching, night after night, they started to notice something weird. A few of those bright lights didn't seem to play by the rules. They kind of wandered off on their own path. They were the wanderers.
Now, we're talking thousands of years ago. Babylonian astronomers. These guys were seriously dedicated, charting the sky night in, night out. And they were some of the first to really pin down that 5 of these wanderers were special. They realized, hey, wait a minute, these aren't stars. They were something else entirely. They were worlds. What we now know as Mercury, Venus, Mars, Jupiter, and Saturn. They had just discovered the planets.
Okay, so you've got these wandering lights in the sky. What's the deal? Well, the most obvious, common-sense answer, which came from early Greek astronomers, was what we call the geocentric model. The idea is super simple, right? Earth is the center of everything. It's stationary. And everything else, the sun, the moon, the planets, the stars, they all just circle around us. And this idea made so much sense that for almost 2,000 years, this was the accepted map of the universe.
But here's the thing. As neat and tidy as that Earth-centered model was, it had a huge problem. There was this one really bizarre thing that the planets did that the model just could not explain easily. It was this nagging clue that just maybe something was seriously wrong with their whole picture of the universe.
Okay, so picture this. You're out there every night tracking Mars. For weeks, it chugs along, moving in one direction against all the other stars. But then, it does something absolutely wild. It looks like it slows down, stops, and then starts moving backwards for a while, before finally going forward again. Seriously, how does that work? If everything is just moving in perfect circles around the Earth, why would a planet suddenly hit reverse?
So this weird backwards dance? It has a name. It's called retrograde motion. And the key thing you gotta understand, and this is huge, is that it's just an illusion. The planet isn't actually slamming on the brakes and backing up. But for ancient astronomers, this optical trick was a massive headache. The heavens were supposed to be perfect and predictable, and this just wasn't.
And then, along comes Nicholas Copernicus in 1543, and he proposes this solution that was, it was completely radical, almost heretical at the time. He basically asked, what if we've got this whole thing backwards? What if the sun is at the center, and Earth, what if we're just another planet going around it?
And just like that, with that one simple change in perspective, the whole puzzle just clicks into place. Copernicus figured out that retrograde motion is what happens when Earth, on a faster inner track, overtakes a slower planet on an outer track, like Mars. It's exactly like when you're on the highway and you pass a slower car. For a second, that other car looks like it's moving backward relative to you, even though you're both moving forward. Simple as that.
Okay, so Copernicus's idea was brilliant. It was elegant. But it was still just a theory on paper. To actually prove it, to convince everyone and completely change how we saw the universe, we were going to need some hard evidence. And that evidence would come from a brand new, revolutionary tool.
So the years after Copernicus were this incredible scientific whirlwind. You had Tycho Brahe, who collected the most mind-bogglingly accurate data of the stars anyone had ever seen. Then Johannes Kepler used that data to figure out that planets move in ovals or ellipses, not perfect circles. But the real knockout punch to the old model, that came from Galileo Galilei and a wild new invention called the telescope.
I mean, can you imagine? Galileo points this simple tube with glass in it up at the sky, and he starts seeing things that were supposed to be impossible. The moon wasn't a perfect sphere. He saw mountains and craters. He looked at Venus and saw it had phases just like our moon, which could only happen if it orbited the sun. And then, the real shocker, he saw 4 little moons orbiting Jupiter. That was it, the proof. Not everything in the universe orbited the Earth.
So in one fell swoop, Galileo's discoveries just completely shattered that ancient idea of a perfect, unchanging heaven. The moon had mountains, just like Earth. Other planets had their own moons. Suddenly, the universe wasn't this untouchable, divine thing anymore. It was a place, a physical place that we could study and understand. And that realization just blew the doors wide open for a whole new era of science.
So the telescope was a total game changer. It let us see our own solar system in a whole new way. But to really grasp the true scale of the universe, I mean, the mind-bendingly huge scale, and to witness its most powerful events, we had to go a step further. We had to figure out a way to see the invisible.
Okay, think about the light you can see, the colors of the rainbow. Well, it turns out that's just a tiny, tiny fraction of all the information flying through space. It's like the cosmos is screaming at us in all these other colors that our eyes just aren't built to see, from high-energy gamma rays to long radio waves. If we wanted the full story, we had to build ourselves some new kinds of eyes.
And that's exactly what radio astronomy is all about. We started building these amazing instruments that could pick up on those long, low-energy radio waves. And by doing that, we basically opened a brand new window into the universe. For the first time, we could listen to the cosmic static. And what we started to hear was just unbelievable.
But to do this, you need some seriously big equipment. Yeah, we're not talking about your standard backyard telescope here. We are talking about absolutely enormous metal dishes, like the Green Bank telescope, engineered to catch the absolute faintest radio whispers coming from billions of light years away.
And then astronomers got really clever. They thought, hey, instead of building one impossibly huge dish, what if we link a whole bunch of smaller ones together? And that's how we got these vast arrays, like the Very Large Array. All these dishes work together to create a virtual telescope the size of a city, or even a country, giving them ridiculously sharp vision. And of course, that quest never stops. We're always trying to build bigger, better, more sensitive instruments. You look at something like the massive 500-meter FAST telescope in China. We are constantly pushing the limits of what's possible, trying to hear just a little bit more from the cosmos.
So what has all this listening actually taught us? Well, we've seen these colossal jets of energy shooting out of galaxies, all powered by supermassive black holes. We actually found the leftover glow from the Big Bang itself. It's called the cosmic microwave background, and it's basically the universe's first baby picture. We discovered pulsars, these incredibly dense, dead stars spinning hundreds of times a second, flashing radio waves at us like cosmic lighthouses. And we can even see into the cold, dark nurseries of space where new stars are being born right now.
When you really boil it down, the history of astronomy is a story about finding new ways to see. We started with just our naked eyes, then we moved to glass lenses, and now we have these gigantic dishes that can listen to the first whispers of the universe. And every single time we've invented a new way to look, we've uncovered a universe that's so much more complex and amazing than we ever could have imagined. So it really just leaves you with one question, right? What are we going to discover next when we invent a way to listen that we can't even dream of yet?